All right, this is 1.4. We're going to talk about parallel, perpendicular, and skew, what those words means when you have lines and when you have planes. Directions say that the diagram below is a right rectangular prism. All the angles shown measure 90 degrees. Name pairs of segments for each relationship below. So it says the diagram below because, look, this is the exact same picture 3 times. And we're going to give some different situations in these 3 boxes here. Okay, so everything is a right angle or 90 degrees. We want segments that are parallel first. So parallel would mean that they are lines that will never touch. So this line and this line would be an example. We got to think back to how do we name lines by 2 letters. Okay, so I would say line RQ. Remember my line segment above it? And then parallel are 2 vertical lines. Don't make it look like an 11, make it a little longer, but RQ would be parallel to QP. That's an option. And again, you could switch orders. It doesn't matter how you do that. So you can run that way. You could do, let me switch colors. These 2 lines would also run parallel. They'll never touch if you extended them forever in each direction. So that would be line PL is parallel to QM. But I put a little note here that they need to be on the same plane. So my orange ones, for example, see how these 2 lines are contained in the same flat surface, this side right here? That has to happen. Or like my first example, the ones that I did in this plum purple color, the top is the same plane. Okay, so I could have done QR and PQ. I could do QP and KL. I could do QK and RN, as long as they're running the same direction and they're found on the same flat surface, then they would be called parallel segments. All right, perpendicular is our next set that they want us to find. Perpendicular, they also have to be on the same plane. So these are 2 lines that are going to butt up to each other. That would make a right angle. So the first example is, let's say, OK with KN. Those would make a 90 right there. So I would say OK. And then the symbol for perpendicular is an upside down capital T. So OK is perpendicular with line KN. And again, the order doesn't matter. Let's do a couple more examples. You could do, there's so many. You could do PL and OP. So line PL is perpendicular to OP. Okay, as long as they're on the same plane. So see how these are on both of these lines are on this front surface. The first example was on the side surface, this left side. You could do MN, N, and K. You could do PQ and QM, RQ and QP. Lots of options. All right, the last one's the trickiest one. It's called skew lines. They have to be on different planes. So these are kind of your random, just random. So let's say we use OK again, because I like having lines that spell something. Another line that would be skewed to that has to be in a different plane. So it cannot be any line that's on this front plane or this left side plane, right? Because this is what OK is on, right? So I couldn't do OP because those would be perpendicular. I couldn't do PL because those would be parallel. I couldn't do KL because those would be perpendicular. Can't do OR, perpendicular. I can't do RN. Those would be parallel. So I have to pick a plane somewhere else. So let's say I go all the way to here and pick QP. There's no line. There's no symbol for skew. So I'll just put and QP. See how these don't touch? They don't share the same plane. So they're always away from each other. And I'll tell you that they're going to be running in opposite directions. So this line kind of runs horizontally, where this line runs vertically. Another example you could pick could be, like, let's say I pick LM. Another line skew to that, so I couldn't pick anything here or on the bottom plane. I would pick RN. So I kind of went opposite there. The thing that I really need you to know is you could not pick OR. Because if you pick OR in LM, they actually are parallel. You could make a plane, remember we talked about you could slice it down the middle like this and actually have a plane be diagonal. So it's very tricky. That's why I tell you the lines need to run kind of opposite directions to be considered skew, because there's imaginary planes that even run from corner to corner diagonally in here. So we couldn't pick OR, but we could pick ML and OK again. We could pick ML and RN. Yeah, we couldn't pick M, and that's really it for those. So that's what skew means. All right, next set of directions say that the diagram below is a right rectangular prism. That means all the angles shown measure 90 degrees. Name two planes that are parallel. Two planes this time. So we're not talking about just lines, two planes. So you could pick top and bottom. Remember that you would have to say plane and pick three letters, WZY, and plane SVU. Any three letters you want. Okay, I'm not going to write plane all the time. You could do left side and right side. So you could say plane WVS and YTX. Plane and plane. Okay, so that's that. Name two planes that are perpendicular. Okay, perpendicular, they need to be two planes that they butt up next to each other, make a 90. So that would be like this front, and it could be this side, it could be the bottom, this side, the top, any two planes, two flat surfaces that come together to make this 90. So I would say plane WST, that was the front, and then plane YXT. So hopefully you get the gist of that. If not, feel free to ask me a question. Okay, and then the last example, diagram below is called an oblique, or it's a slanted rectangular prism. So it's like you try to build a box and it's leaning. Not all angles shown are 90 degrees. So that means that we would have no planes that are perpendicular, because perpendicular specifically means that they form 90 degrees. Okay, so part A says name two planes that are parallel. Again, that could be the top and the bottom, the front and the back, the side and the side, because these planes, if you laid paper on each side, they would never touch. So they're leaning in the same direction. So I'll just do top and bottom. Plane SPQ and plane LON. And I'm not going to do more examples on that one. All right, and then part B, name two planes that intersect, but they aren't necessarily perpendicular. So intersect would be they're touching, they're crossed, they're lined, they're butted up with each other, but they're not going to make 90. So that could be this front plane and this side. So I'm going to say plane PLM and plane RQM. Okay, so you could do those. You could do this left side and the front. You could do front and the bottom, top and the front, top and the back. Lots of different options there. Just know that they're not perpendicular. They're just intersecting. And if it ever asks you, like, where do they intersect? They would intersect at the line that both planes share. So see how the side and the front would meet right here at line QM. Couldn't tell if that was Q or no. So there you go. There's parallel, perpendicular, and skew.